For math packet number 11, we are going to go through it. I'm not going to totally work it out with you how to do it because we should be able to work out these word problems our own. I'll just give us some hints. Okay. So for the first page, Janet's family was having a reunion at the picnic grounds. She bought 10 pounds of hamburger and could make 4 hamburgers per pound. Her family ate 34 hamburgers. How many pounds of hamburger meat did she have left? So let's think about that. If her family could, she bought 10 pounds of hamburger. So, oops, dropping my pen. She bought 10 pounds. Maybe it'll write for me. Okay, it is not wanting to write. Always fun. So I'll write on my paper. She bought 10 pounds. And for 1 pound equals 4 hamburgers. We need to figure out how many hamburgers, how many pounds 34 hamburgers uses, and then see what's left over. So if you know 1 pound is 4 hamburgers, how many hamburgers would 10 pounds make? We only need 34 hamburgers, so you need to see how many are left over. How many pounds would be left over? So if 1 pound is 4 hamburgers, think how many hamburgers 40 pounds makes. Think about how many extra hamburgers that is. How many pounds would that be? So if you find how many leftover hamburgers there would be, because we only need 34, you can always do something like our bar model that we've talked about. So if we could break this into 10 pounds, each pound is 4 hamburgers. We want to go up to 34 hamburgers, see how many pounds are left over. So if I have 4 hamburgers here, 1, 2, 3, that makes it 8 hamburgers. That makes it 12 hamburgers. That makes 16 hamburgers. Go all the way up to 34 and see how many pounds you have left over. So you can do it using a bar model. You can do it by working out the math. Ryan?
Wait, what's the next one? Look for how many pounds you need? 30 something?
Well, look up at our problem here. Her family ate 34 hamburgers. So how many pounds of hamburgers left over? Let's look at our next question. A train is going from Lilywood to Hermantown, along the way stopping at Green Lake and Highland Hills. At Lilywood, there are 108 passengers on the train. Several people get off at Green Lake and 26 get on. In Highland Hills, 24 people get off and 3 people get on. When the train reaches Hermantown, there are 71 passengers on the train. How many people got off at Green Lake? What I do is I draw my line. We're starting at Lilywood. I don't know how many people they start with. Oh, nope, I take that back. I do know. At Lilywood, there are 108 passengers. We're going all the way to Hermantown. We know that we stop at Green Lake and at Highland Hills. So at Lilywood, there's 108 passengers. Several get off, so we don't know how many to subtract. but we know that we're going to add 26. At Highland Hills, we know we subtract 24 people and 3 people get on. And when we know when the train reaches Hermantown, there are 71 people. So how many people got off at Green Lake? That is our question. Do you think we could work our way backwards? So if we know we were subtracting 24 going to the right, if we're going to go to the left, what are we going to do with that 24? Add them. Going to the right, we added 3. What are we going to do going to the left? So here we're adding 26. We're going to have to use that 108 there. See if you can work out how to find that missing number. It always helps me when I draw the picture of my word problem and I know, oh, I can work my way backwards, doing opposite operations. Try to find that missing number. Our next page is our 5-card challenge. Make sure we equal 7. Shh. Why are we yelling out any numbers? On this page, it says find the area of the shaded region. That is a goofy shape. What do we have to do to find a goofy shape? What are we going to have to do, Tristan? Turn it into shapes that we know. Well, this goofy shaded shape, that would be a lot of work. So I think it's easier. We know we have to find the area of our full figure. So it is 8 centimeters and 9 centimeters. We know that area is length times width. So we should be able to find the area of the full figure. We're going to want to find the area of the white because then we can subtract that out of the full figure to find our shaded. The white we can break into 2 different shapes that we can find our area of. So if you break it into 2 rectangles, subtract that from the full figure, you're left with the shaded amount. So you're going to want to either break it going this way or break it going this way. Doesn't matter which way we break up the white. Find the area of the white, subtract it out of our shaded. Our next page is our pattern page. Complete up to the 6th figure. So we need to go all the way up here. We need to complete the whole table. Finding our patterns. How many green are there in the first figure? How many blue are in the first figure? 8. So how many altogether? 9. Do that for the first 4. Count how many green, count how many blue. See if we can find our pattern. Tristan, how many blue are there? Is it 16? Yeah. So we add the green and the blue together for my total. You're going to do that for each of those first 4 figures. Find the patterns. Continue that pattern. All right, let's go over our formulas. You need to complete at least 2 of these. Who can tell me what the formula is for the volume of a rectangular prism? Gabby. Length times width times height. What about for a cube? Tristan. Side cubed. It's the same thing as saying length times width times height, but we know all of our sides are the same length. So we need to remember that for our cube, it is side cubed, which is the same as saying length times width times height, but we need to remember they're all the same number. What about our triangular prism? Who remembers? It's like our rectangular prism with length times width times height, but because it's triangular, we divide by 2. What about our pyramid? Length times width times height divided by 3. Our cylinder, we have our area of our circle, pi r squared times the height. Our cone is pi r squared times the height divided by 3 because we're taking it out of that cylinder. And our sphere is 4/3 pi. Let me see if I can remember it. 4/3 times pi r cubed. So find 2 of them. Challenge yourself to find more. Mean, median, mode. Create a data set of 5 numbers that have a mean of 20. If we add all 5 numbers up and divide it by 5, we get 20. It has a median of 16. Your middle number needs to be 16. And a mode of 30. The number you use the most is 30. So you're going to need 5 numbers. That median is going to be 16. And you need a mode of 30. Ooh, that gives us 3 numbers right there. Because we know we need 2 30s. So we need 2 numbers smaller than 16. That if we add all 5 numbers up and divide it by 5, it will equal 20. So you're going to have to try to figure that out. Sometimes it's a guess and check. Just keep in mind they have to be to the left of the 16, so they need to be smaller than 16. Our last page is making a graph. We need to remember it says you can use a different sheet of paper or you can use this bottom space. Make sure it's accurate and neat so I can read it, and make sure you do correct labeling. So if I'm going to make my graph right here, what do you think, how should I label my left and my right? I need to show a graph that represents one type of meat. So what should I write on the left and what should I write on the right? Tristan, what do you think? So I've seen it done in 2 different ways. I've seen it done as a bar graph and I've seen it done as a line graph. So it's going to change how you label it if you do it as a line graph versus a bar graph. Which way did you do it, Tristan? You did a bar graph. So how did you label it for a bar graph?
I just labeled the numbers on.
And so what would the numbers be? What label would we give to that side? I'm going to point out our geometry section. It tells us that sales pattern. So we're going to write sales pattern. How should I label the bottom? Seasons. Because we have seasons here. So our numbers are the sales pattern. And on the bottom, we have the different seasons going across. Now we're going to put our title. We're going to put which type of meat we chose. So let's say we chose lamb. I'm going to label it lamb sales. So on the bottom, I would put 2002 winter, 2002 spring, 2002 summer, and I'm going to keep it going. Going up the side, I'm going to put numbers that go with these. So I might, let's see, I'm going to skip. Remember, we learned when we did graphs that if you put that little squiggle at the bottom means you don't have to start at 0. So I'm going to start it at 60. Then I'll put 61, 62, 63, 64. I'm going to count up by ones all the way up to 87. Does your graph have to be identical to mine? No, sure doesn't. It does need to be accurate. So for my first bar for winter, I'm going to put it up to 70. Okay. For my second bar, it's 62. And you're going to continue it for the rest of the sales. You could do it as a line graph. And you could have the seasons and the numbers with the type of meat being connecting. You could connect the dots. Anthony?
So you don't have to use all the numbers?
You do. You need to finish it. I'm not doing the whole thing for you right now so you can just copy it. You have to finish the graph. Show that you can finish it. I got you started. You need to finish it. Do you have to do it for lamb? Nope. You could choose a different meat. For one type of meat. So it's always important that we read the full directions. I even circled it. We only have to do one type of meat for Math 6. Okay. So we're going to close off there. Good luck. Remember that this is due next week, Thursday, May 12th. If you are watching at home, we hope you are well. We hope that we see you soon.